Now we calculate the arc length of this curve from t equals 0 to 1. The result is going to be pretty obvious. This is going to describe half of a circle of radius a, the circumference of half the circle, and the result's going to be extremely obvious, but let's illustrate the process. So the arc length is going to equal the integral from a to b. Here a is 0, b is 1, of the magnitude of r prime of t dt. Now, magnitude of r prime of t is what? We've already calculated the magnitude of r prime here. We see that it's pi a, and it's going to lead to a very simple integral, but let's go ahead and use the formula r prime, magnitude of r prime of t is the square root of x prime squared plus y prime squared. Now ordinarily we'd have a z prime squared, but there's no z component on this vector, so that's it. Where x of t is the I component, that's a cosine of pi t, so that x prime of t is negative pi a sine of pi t. We're still on the screen there. And y of t equals a sine of pi t, so that y prime of t equals pi a cosine of pi t. Our square root of x prime plus y prime then is x prime squared is negative pi a sine of pi t quantity squared plus y prime squared being y a cosine of pi t quantity squared. This equals, well, this is identical to the expression that we would have had up here. That comes out pi a, and you should be able to easily verify that. If you can't, ask for a little more explanation, but that should be reasonably clear. So that our arc length is the integral from 0 to 1 of pi a dt. Now, with most functions that we're going to encounter, the sines and cosines don't match up perfectly, and we end up with some sort of t dependence here, so we got to do a little work to integrate the expression. In this case, pi a is just a constant. The integral of dt is t, so we have pi a multiplied by t evaluated between 1 and 0, and that just equals pi a times 1 minus 0, and that's just pi a. This is a circle of radius a. At t equals 0, we're at the point 1, well, the point, well, let's sketch it. At t equals 0, our r of t vector is just ai, putting us at the point a 0. At t equals pi over 1/2, this is a cosine of pi over 2 plus a sine of pi over 2. So we have the point 0a at t equals 1/2, and negative a0 at t equals 1. The magnitude of this r of t vector is always just a, so we are describing an arc of a circle whose radius is a. We're describing half the circle between t equals 0 and t equals 1. The circumference of the circle is 2 pi times the radius, 2 pi times a, so the circumference, or the arc of half the circle, has an arc distance of pi a.